So today we'll start section 2.7, graphs of rational functions. And this shouldn't be too bad. There's only one real new thing to learn. So one of the nice things I did is, while we were doing the last few sections, I was sketching as we went, even though it didn't always ask you to sketch. You know, it only asked you to find like asymptotes and things like that. So I did some of this stuff so that you'd be prepared when we got here. So this shouldn't be too much new. There'll be one new thing we'll learn today. Other than that, it's pretty much just putting these steps down. So you have your note sheets that I passed out, and you'll put these on your note sheet. But if you jot them down, then we'll sketch some things. But basically, when you're graphing a rational function, that's just a polynomial for a numerator and a polynomial for a denominator. And they both have to be polynomials. So in other words, this doesn't apply to sketching something over 7, because 7's not a polynomial. Which is a good review. What is a polynomial?
More than one.
What is a polynomial?
More than one, like.
At least two terms.
Yeah.
Separated by either addition or subtraction, right? With a variable in there. And it's got to be in order from highest exponent to lowest exponent. Okay. So the first thing you do is simplify when possible. So whenever they give you a function, you'll have to simplify. So let's see. Find and plot the y-intercept, if any, by evaluating f at 0. Okay, so did I put that on this page or the next page? So let's do one, rather than all these rules are in your book, and then on your sheets you'll have them there. So let's sketch the graph of y, g of x equals 3 over x minus 2. Let me get a whole. All right. So we have 3 over x minus 2. So step 1 is to simplify that. Can you simplify that any more than it is? No. So we just go on to step 2. Find and plot the y-intercept, if any, by evaluating f at 0. So if I put in a 0 for x, what point am I going to get for y? Negative 1.5. Okay. Close enough. So that will be our y, y-intercept. Number 3, find all the zeros of the numerator, if any, by solving the equation, and set the numerator equal to 0. Well, there are no zeros in the numerator because you just have a 3 up there, so there would be none for step 3. Number 4, find the zeros of the denominator, if any, by solving the equation. Okay. So are there any zeros in the denominator?
Yes.
Where's that at?
Okay. 2.
At x equals 2. So right around there, there's our x-intercept. And that's the only one. So then we would go, it says find the zeros of the denominator by solving the equation, then sketch the corresponding vertical asymptote using dashed vertical lines. So actually, I pointed that, but that's not on the line, right? Because you're going to have a vertical asymptote. So let's get a dashed line. Was it 2? So I just love that. Okay. So that we have a vertical asymptote for this graph, and we have a y-intercept. Okay. Now step number 5, find and sketch the horizontal asymptote, if any, of the graph using a dashed horizontal line. Is there a horizontal asymptote?
Yes. 0. Y equals 0.
And what do you think, Kelly?
What? Sorry, I was writing.
Do I have a horizontal asymptote?
Yes. I don't know.
What's that?
I don't know.
Well, there's three rules. You know they're not equal. The degree, you're comparing the degrees. So you have a 0 degree on the top for the numerator and a 1 first degree on the bottom. So we know they're not equal. So is this the one with no, it's either the one with no denominator or the one with the x-axis as a horizontal asymptote. And which is it? What did you say, Ben?
0, y equals 0.
Which is the x-axis.
Yep.
Because the numerator is the degree of the numerator is less than the degree of the denominator. So we know that the x-axis is also a horizontal asymptote. And then step number 6, plot at least one point between and one point beyond each x-intercept. That means just plot any point on either side of that vertical asymptote. So we can pick any place. So let me just get a different color for that, just because we don't want it to be the same color as our. Okay. So what point could we plot? You can plot any, put an x in for any of these on this side. Just pick one.
2. No. You can't do 2. How about 3? Yeah, 3.
3 is 3, 3?
Yep. So 1.
Oh. X is 3, and y is
1. No.
3.
3.
Right?
Yeah, you are right. I can't even think.
I like to make sure. I don't. All right. Okay. Then pick one. Pick another one on the left side.
-1.
All right. -1 will give us -1.
-1.
-1. -1.
Yes.
If you have a -1
No,
here, -1 minus 2 is -3. -3 over 3 is
That's
-1.
not the right point, though.
Oh, yes. I went to the positive one. -1. Okay. Well, you have now sort of enough to see what's happening, I think, on this side, because I think you can see where you're approaching. You see what you're doing there. Do you have enough here to see what's happening?
Not yet.
Okay, so it says point at least 1, and I can tell what's happening because I can see what that's doing.
Well,
but you
I
can,
know
but if you
it's-
don't,
I know
that's
it's-
fine.
I know what it's gonna do.
What's it going to do?
It's gonna go.
Like this way?
Yeah. It's just not touching.
Yeah. So that's what your graph is going to look like. Okay? And so it's just basically following these steps one by one. I don't know that you need to memorize them all, but you need to have everything in. So once I sketch the graph, if you don't, you want to do your asymptotes, you want to make a smooth curve, you want to plot your intercepts, plot some points. Okay. Now, this is all pretty much old stuff. There's nothing that's new. It's just put it together in the graph, which we kind of did as we did the other sections, so that really shouldn't be too new. This is the only new part. So we've learned about vertical and horizontal asymptotes. So today we're going to learn about slant or oblique or linear asymptotes. Okay? So you can have asymptotes that aren't horizontal or vertical, that are just regular lines. Can be an asymptote. And that will occur if the degree of the numerator is exactly 1 degree higher than the degree of the denominator. The graph of the function has a slant or oblique asymptote. Okay? So if I have a function, a rational function, where notice that my degree of the numerator is 2, my degree of the denominator is 1. So because my numerator is exactly 1 degree higher than my denominator, that means I'm going to have a slant asymptote. Okay? And where that's going to be depends on what your quotient is. So let's do that, and I'll do it down. Somebody write that down so you can, well, x squared minus x plus 1. X squared minus x over, what was that, x? Plus 1. Okay. So, the first step is to simplify this. How can I simplify this thing? Yeah, sure you can. You can factor that. You can make this smaller than this. What can I do to the top here to simplify that? You can do that. Huh? If that's what I want to do. Okay. What else can I do? Is there anything else? Nothing else?
Also, it has to do with like the, whatever the reciprocal things are. I can't think of what it's called, but it would be like x minus 1 times x plus 1.
You could multiply everything by -1 over -1. Is that what you're talking about?
Oh, no, I'm just kidding.
Is that what you're talking about? Just make everything opposite signs?
That's not what I was thinking.
Okay. That wouldn't, because it wouldn't help either, because it would get this to x minus 1, but this would change to plus, so they still wouldn't cancel out.
No, I meant, I can't think of what it's called, but then you would do that whole thing times x minus 1. Or
Well,
x minus 1.
this times this equals this
No,
times
no.
this?
No, I don't, just never mind.
Okay. I don't see any other way to simplify this. So how am I going to find the quotient then? Okay. What did we learn in the last section when you divide polynomials?
I know that you're missing out on pictures you gotta get.
How am I going to divide this by this? You could use synthetic division, or you could use long division, whichever you prefer. If I do x plus 1 over x squared minus x,
You're taking the minutes,
can I do that?
Yeah.
What will I get?
X.
I'll get x,
except the fact that it's, why is this so fuzzy?
which will give me x squared plus x. X squared plus x. So I'd have to subtract that and then subtract this, right?
Yeah.
Which would give me,
That gives 2x.
then what?
I don't know.
It's just regular long division, it's the same as what we had before.
Multiply.
2 plus 2. Yes, minus 2.
Minus 2, right? Because minus 2 will give me this
Oh.
thing, right? Minus 2x
Plus 2. Minus, no, minus,
plus
minus 2. Minus 2.
minus 2. But it's going to be plus because I'm going
Yeah,
to change
that's
my
gonna be
signs,
plus,
right?
So you're going to be left with 2.
So I'd have a remainder of 2.
But what
Or
is y?
2 over, why would I?
Wait, what?
That's our remainder, right? 2 over our
Oh,
divided.
yeah, that makes
Because-
sense.
No, I'm sorry, that's a plus right now. It's not multiple, but I think it multiplies. Okay. So what does that tell us?
I don't know, what does it tell us? I'm confused.
Okay. Because this is my quotient, that's going to be a slant asymptote.
What?
The line x minus 2, because that's our quotient. This equals x minus 2 plus, what did I say, 2 over x plus 1? This is the same as this. You agree with that, right? This divided this is this. That's just long division. What I'm telling you is this quotient here, before the remainder, is your slant asymptote. So what's a slant asymptote? Well, what does that look like? What is the line x? Oh my goodness. Let me move that to.
Just y plus x, but down 2.
Oh, I linked those. So all right. It's, I'm sorry, say that again? If I want to make the line y equals x minus 2, what am I going to do?
Just shifted down 2.
Right, with a regular positive slope of 1.
Yep.
So it will look something like this. No, it won't look like that. Because it's an asymptote.
Oh, yeah.
It will look like that, though. Okay. So that's the only new information is when you divide them, your quotient before the remainder is a horizontal asymptote.
Oh.
It's not horizontal, sorry, an oblique or linear or a
Okay.
slant asymptote, as they call them different things. So that's an asymptote. So now all you do is all your rules from the first part that we talked about. So if we want to graph this, simplify it if possible. It can't really be simplified much more than what we've already done. There's no way to cancel them out. If you had no remainder, you could cancel things out and simplify, but you do have a remainder. So this is pretty much in the smallest form that you're going to be able to get. Okay. Find and plot the y-intercept by evaluating f of 0. So if x is 0, what's my y-intercept? If I put in my function here, if I put in x 0 for x, what am I going to get for my y value?
What do you mean?
If I put a 0, sorry, this
0, yeah, 0.
Let me move this up a little bit so you can see that whole function. I made my graph too big. Right, 0, 0.
I know, I don't get it.
Okay. That's step 2. Step 3. Find the zeros of the numerator, if any, by solving the equation. Make the numerator equal to 0 and make the x-axis. So x squared minus x.
0.
Well, this is where, remember what we did before? We said x times x minus 1, right? So we have an x intercept at x equals 0, which we already plotted. And what's our other one? It's at 1. So next, find the zeros of the denominator, if any, by solving the equation, the denominator of x equals 0, and then sketch the vertical asymptotes. So at -1, x equals -1. Okay. And that was my getting the graph so big. I shouldn't be such a perfectionist because you know what's happening whether I draw it or not, but okay. All right, that's the graph. So we got our vertical asymptote. That's the only one. So number 5, find and sketch the horizontal asymptote, if any, of the graph using a dashed horizontal line. Is there a horizontal asymptote?
No,
Why?
because the numerator's exponent is bigger than the denominator.
Because, right, your degrees are 2/1, and because the numerator has a higher degree, there's no horizontal asymptote, so we just skip that one. And then last, or 2 left. Plot, number 6, plot at least 1 point between and 1 point beyond each x-intercept and vertical asymptote. So the idea is just in each of these sections, plot at least 1 point, is the idea. So it doesn't matter which one, but I'm guessing I want to be over here, so and I've got 1, 2, 3, 4, 5. So let's pick 5. What's 5 going to give me?
20 divided by 6, which will be 3 point something.
3 point something. 1, 2, 3, 4, 5. 1, 2, 1, 2. And it was really close to that.
Boy, did you learn a lesson, huh? Several? Well, that's always good. It's good to learn something.
All right, so Kelly, then you give me a point now. So that's 1 in there.
You got Joe on one side.
What if we pick 1, 2, 3? See what's happening at 3.
6 over 4, which is 3 halves.
Which 1.5? So we're still in there. Okay. Any other points here, Ben, you want to plot?
I think I see what it's doing one way.
You think so? Okay, good. What do you think it's doing? Just so we're on the same page.
0, then goes back.
you think it's doing something like this atom?
What? Wait, why did it do that?
Well, it can't touch this asymptote either, right?
Oh!
Do you think it was doing something like this?
Oh, yeah.
Getting close to that. That's
saw
what that,
that
that's
side.
what that part's doing. Okay, but we still have no idea down here, so we still have to do something down here, right? So,
Let's try -2 then.
let me, this was x squared minus x over x plus 1, right? Okay. Then we don't have to keep shifting on the right. Okay, sorry, go ahead. Which number?
Hot -2.
Negative 2 will give me 4 plus 2 is 6 over negative 1, negative 6. Negative, right?
Oh, yeah.
2, 1, 2, 3, 4, 5, 6. Yeah, right about there. And is that enough to know what's going on, or do you want to pull out another one, Kelly?
Well, it's gonna look exactly the same as the top one, just the opposite.
Right. So. So it's gonna get really close to that. Get really close to that. It wouldn't cross that line, but we'll draw. You get the idea. That's the whole thing with the slant asymptote and graphing that. That's what this whole section is. There's really not anything more than that. So you have to use you notice all these sections build off what you learned from the previous. So you have to know how to do your division, your long division, to come up with what your slant asymptote's going to be. And then you just use everything else you have to graph. And that's really all there is to it. And you've got about 12 minutes, so you can start the homework. We'll work on your sheets, however you want to, whatever you want to start. I'll grade your quizzes. Hopefully, I can have them done before you leave. But that's all there is to those.
Is this the last section?
I think there's one more after this.
Oh, I gotta get the extra.
There's 2.8. Yeah, I'll get that for you tomorrow. I'll have to pass that. I'm not tomorrow, Monday. So yeah, there's 2.8. What I tell you, the last section is always going to be in the chapter. No. What's the last